So that matches my story. My diagonal is 4 centimeters longer than this, and the other side is 8, which makes this 8 and makes this x. Maybe I'll write that down because we do have to find the perimeter. I have x and 8. Now, like a lot of you found out, do I have any way to say that this is 60 degrees, 45 degrees, or anything like that? Do I know what degree measure this is? All I know is this is 90, so that means that I have a 90-degree triangle. I have a 90-degree triangle, and it's this guy. This guy right here is a 90-degree triangle. Well, since I don't know 30-30, or 30-60-90, I don't know 45-45-90, I'm going to go, hey, I can use the Pythagorean theorem. In fact, whenever you know two sides, or a hypotenuse in a side, or anything like that, you can always use the Pythagorean theorem. So our Pythagorean theorem is a squared plus b squared equals c squared, which is side. So I'll say 8 squared plus my other side is x squared equals my hypotenuse squared, which is x plus 4 squared. Well, just some quick side work to make sure you did this correctly. This would be x plus 4 times x plus 4. Let's do all the work really, really quick. We do x times x. Oof, that's a big line. Let's get that down a little bit. So I do x times x, which would give me x squared. I would do x times 4, which would give me 4x. I would do 4 times x, which would give me 4x. And finally, I would do 4 times 4, which would give me 16. So we have 8 squared, which is 64, plus x squared equals x squared plus, well, I really have 8 x's. And it'll be plus 16. I need to get all my variables on one side, all my numbers on the other. So I'm going to subtract x squared from both sides. Gone, gone. I'm going to have 64 equals 8x plus 16. Subtract 16 from both sides. You're going to see you have 48 equals 8x, which tells me x equals 6. Is that my finished answer? Did they ask me what x equals? No, they asked what my perimeter equals. Well, my perimeter is x plus 8 plus 8. So my perimeter, I'll make a little thing here, my perimeter, that's going to equal all my sides added up, so that's 8 plus 8 plus 6 plus 6, which is 16 plus 12, which is 28. My perimeter is 28. Okay, what we're going to talk about today are Pythagorean triples. So hopefully no one started the homework and just did regular Pythagorean theorem, because that's not what we're doing today. We're doing Pythagorean triples. So the difference between Pythagorean triples and the Pythagorean theorem is the Pythagorean triples, we don't have to use the Pythagorean theorem. We just have to recognize a particular pattern. So I don't think we did this right. Did we? Yeah, because we just used Pythagorean triples. Make sure you read the directions on the homework, all right, before you just get started on it. So Pythagorean triples, those are going to be whole numbers. Let me get the actual. It's 3 whole numbers where a squared plus b squared equals c squared. And what does it mean if I have a squared plus b squared equals c squared? What do I know about that triangle? Yeah, it's a right triangle. So these are 3 whole numbers where my 2 legs and my hypotenuse are all whole numbers. That means no fractions. Decimals, radicals, and anything else. It has to be a whole number. And there's tons of these. There's tons of these triangles that are perfect whole numbers where our hypotenuse comes out perfect. And the most common ones, ooh, I wrote that on the long line. Let me copy and paste that and put it on the next page, so we can look at it. And, ooh, they're traveling too much stuff over there. Get rid of that guy. Okay, the most common Pythagorean triples have the bases of these. These are called our primitive. They're called our primitive ones. These are primitive. So whenever you ever see a primitive Pythagorean triple, that's what they're talking about. So any triangle with leg 3, 4, and a hypotenuse 5 is a right triangle. And if you plug that in your calculator, if you do 3 squared plus 4 squared, it will equal 5 squared. Just like 5 squared plus 12 squared equals 13 squared. Just like 8 squared plus 15 squared equals 17 squared, and so on. The awesome thing about the primitives is I create similar triangles by multiplying by 2 or any number I want to. So if 3, 4, 5 is a right triangle, that means 6, 8, 10 is a right triangle because I multiplied every number by 2, so it's a similar triangle. Basically, I took a magnifying glass and made it bigger. If I multiply this by 3, I can come up with 9, 12, 15. I can multiply these by any number. That's why we said any triangle of this form. If I do 3 times some number, 4 times that same number, 5 times that same number, it will make a right triangle. The nice thing about these triangles, if you memorize these, or know them, and usually people just stop here. These are like the real major ones. We have 4 of them here. There's actually more primitive ones. It's hard to memorize every single primitive triangle. But if we could have those memorized on the test, we could look at something like 16, 34, and x. And normally I have to do the Pythagorean theorem, which would mean I would have to have a calculator or something. Yeah?
X equals 30.
X does equal 30. Let's get to that, though. Nice job. X is going to equal 30 because if I really quick, I'm going to draw a similar triangle here. And I'm going to say, well, 34 and 16 are both divisible by 2. So I'm going to draw a similar triangle, which would mean I'm going to use 17 and 8. I just divided both things by 2 to get a similar triangle, 17 and 8. So that tells me I can look at the primitives, 17, 8. And my missing side on that one is going to be 15. Well, 2 times 17 is 34. 2 times 8 is 16. 2 times 15 is going to equal that 30. And the reason why I went through those steps, even though you have that nice little table up there, do you want to memorize this entire table? Probably not. You're probably more or less just going to memorize these first 4 perfect squares. You don't want to memorize every possible possibility out of here. So we just memorize these primitive ones, and that way we're going to convert any of these into a primitive one. So I'm going to look at 25 and 60, and I'm going to draw a similar triangle. You don't have to draw a similar triangle. You can just think in your head. What number goes into 25 and also goes into 60? Mary? 5 goes into it. 5 goes into 25 5 times. 5 goes into 60 12 times. Is there a primitive Pythagorean that goes 5 12? No, you're shaking your head. Yes. What would my hypotenuse be on that one?
13.
13. Well, 5 times 5 gives me 25. 5 times 12 gives me 60. That means 5 times 13 is going to give me my A. So A is going to equal 5 times 13. Yeah, Chris?
Are you able to use the chart on the test?
I don't think so. I'm going to double check with that. I wouldn't, but if he's going to, I'll let you guys use it. Because it really is only a couple numbers. It's a few numbers. And realistically, if you forget these numbers, you can always fall back on using the Pythagorean theorem. But on the homework, I want you to use these triples. I don't want you to use the Pythagorean theorem, because just seeing them over and over, like 3, 4, 5, 3, 4, 5, 5, 12, 13. These are going to be triangles that are going to appear over and over in your math career. So the sooner you know 3, 4, 5 is the right triangle, the easier it is on you. That's why we're practicing. I don't want using the Pythagorean theorem on the ones that say specifically use those primitive ones, okay? That's why we're going to practice using them. But we can also fall back on the Pythagorean theorem, but you don't want to do it every single time you see a 3, 4, 5 triangle. I want you to be able to spot those quickly, okay? I do want to go over one question on the homework. So 1 through 6, you have to use Pythagorean primitives. I do not need to see you drawing a similar triangle. You can just kind of look at it. Well, this one already is in the form. If you need to simplify something, you can do it in your head, or you can draw another triangle. That's good. Pythagorean triples again. This one you're going to be using 45, 90, 30, 60, 90, and you're going to be using Pythagorean triples. Same thing with that one. These are a bit different. All of these are something called the unit circle. They will be your life when you get to pre-calculus for about 2 months. Alright, so why not see it now? Now, what a unit circle is basically we take this, so we take an xy plane, and I take a radius of 1. And think of it as being a stick that I just kind of spin around. It can spin and spin and spin and spin, and it creates this circle on the very end. Alright? So each of these segments is 1 unit long. So that's 1 unit. That's 1 unit. Here it's 1 unit, 1 unit. That's why it's called the unit circle. Everything is 1 unit away from the origin. Well, the cool thing about the unit circle is it creates lots and lots of angles. Alright, so we're going to do this, let's do number 20 together. We'll do number 20 together. So I took my spinner and I spun it and it stopped right here. Alright, I want to figure out what point this is. Where did it stop on the xy plane? If this is -1, that's 1. I want to figure out what point makes this, what x, y values make this point. In order to do that, I am going to drop this down onto the x-axis to create a right triangle. Because remember, using the xy plane, I just need to figure out how far left did I go and how high did I go. That's how the xy plane works. Our coordinate plane works by giving me an x value and a y value to tell me where to. I just need to figure out how far left did I go and how far up did I go. And that's what I create here, left, up. So I need to find this value and this value. So we have 150 degrees. This whole thing is supposed to be 180. So what measure is that little tiny sliver there? 30 degrees. So this is 30 degrees. That's 90, so that makes this 60 degrees. All right. I also know the hypotenuse is 1. All right, let's hold that, put a pin in it for a second. I have a 30, 60, 90 degree. How can I label the sides and the hypotenuse? We're going to do this every time we see a 30, 60 triangle. What I'm going to label them as. Grace?
S, 2S, and S squared.
Yep, can you tell me where the one across from 30 degrees is going to be S? My hypotenuse is going to be 2S. And that means my last one is going to be S square root of 3. Yep, awesome. But like I said, our hypotenuse is 1. This whole length here is 1. Anywhere on here is 1. So I'm going to tell you right now, 2S equals 1. Well, if I divide both sides by 2, I'm going to see that S equals 1. So that means the distance from here to here is 1. So what's my y value? What's my y value? Oh, I didn't divide it. Yeah. Ah. S should equal, I said it, I just didn't do it. S should equal 1/2, not 1, because it turns out 1 divided by 2 is not 1, oddly enough. So it equals 1/2. So what's my y value going to be in this? If this point tells me how high and left, remember it's just x, y values. What is my y value? Okay, if we don't know, we'll move on. So let's move on and we'll do our s square root of 3. We'll finish our triangle. S square root of 3 is going to equal, well, if I plug 1/2 in there, it's going to be 1/2 times square root of 3, which is square root of 3 over 2. Well, that's an important one. That's an important guy because this length right here is going to be square root of 3 over 2. Our s, we said, was 1/2. So what's our ordered pair that gets us to that point? Peter?
Negative, and then 3/2, and then comma.
Perfect. I'm glad you threw that negative in there. So the ordered pair is going to be negative square root of 3 over 2. And 1/2, because that tells me how to get there. I go negative 3 over 2 left, and I go up 1/2. Yeah, Mary?
So is the reason then radical 3 over 2 is negative is because we went to the left?
Yep, we're on xy coordinates, right? Because all those values to the left of 0 are negative.
Yeah, so like also if like for whatever reason if 1/2 was negative, then you don't, you went down from 1/2, then,
Kind of like here.
oh, yeah,
Right, and the next one, our x is going to be positive and our y is going to be negative.
okay, so just treat it like a normal graph.
Yep, treat like you are on a graph. You don't just treat it, you actually are on a graph. We put a circle on a graph, and we said, I got this spinny arm that's 1 unit long, I'm going to spin it. So I am on just a regular xy coordinate plane. We're going to treat it just as that. All right, any questions on that? All right, let's go ahead and finish our homework.